Okay, so I wanted to just finish up this problem that we didn't quite get to finish in class. So what we were doing, we found essentially the um, of derivative of the function, derivative of the function f of x equals x to the fourth minus 5x, right? And we ended up finding out that that derivative was just 4a cubed plus 5. But I didn't get to finish the punchline. What are we seeing? Now remember, this whole thing, the whole derivative, came from finding the slope. So what we have found here is the slope of this original function at any given point. So now, the second part of this was saying find f prime of 2. So you can see that's right up here. Find f prime of 2. So what would that mean? So that just means we take our f prime function, our derivative function, substitute in a 2, and let's figure out what that is. So then 2 cubed is 8. 8 times 4 is 32. 32 plus 5 is 37. So what is that? Well, this is the slope of the line at the x value 2. And I guess I should say, when I say the slope of the line, what I actually mean is the slope of the tangent line. So let me see, that graph was a quartic. Let me get that in the calculator here. So you can see, let me make sure it's fully on the screen. So you could see on the calculator what this graph looks like. It's not quite parabolic, but it's kind of got that U shape to it. And you can see at 2, our y value is whatever it is. But you can see it has this kind of shape to it. So let me just kind of sketch that real fast. So what we're seeing here is something like this, right? Now at the y value of 2, that would be our point right there. What we have found now is the instantaneous rate of change at this point. What's the slope of the tangent line at that point? Well, we can see it should be a positive number, and it should be really steep. So when you go back and look at the actual calculator, you can see, when you're looking at 2, the value right there, the tangent line that you would draw there would be a very steep line going right up and down because it has a slope of 37. So I should actually make it even more steep. It's kind of, there you go. So you can see the slope of the tangent line, there we go, very, very steep. So now we have gotten those points so close together. In fact, they're so close together, we're just going to say they might as well be 0. So therefore, the instantaneous rate of change at the value of 2 is 37. So for those of you, that's all you need. There you go. For those of you who want a little more, let me walk you through a more simple example for those of you who may be struggling with the concept and see if this kind of solidifies it for you. Okay, so I'm going to do just the equation x squared plus 1. Okay, this will be a little, actually, you know what, let's make it x squared plus x, because I think we can probably handle that. Okay, so now let's find the derivative of this function. So the very first thing we're going to do is say we want f prime of a, which means we have to go into the formula of f of a plus h minus f of a divided by a plus h minus a, just the slope formula. And then, like we said in class, every single time the x's, or the a's in this case, are going to subtract away. So that's going to leave me with f of a plus h minus f, minus f of a all over h. And then, of course, to be able to do this, we need our h to have a limit as h is approaching 0. And we can't lose that over here. So again, the idea, remember the big concept here, is we want these points to be so close together that essentially it's the same point. So essentially it would be having f of a minus f of a as close as you could ever possibly get them. Okay, so to be able to fill into this equation, the first thing we have to do is just figure out what is f of a plus h for our function that I have just written down. All right, so here we go. Our function is just x squared plus x. So f of a plus h would be a plus h squared plus a plus h. Okay, so now when I FOIL that through or distribute that through, that's going to give me a squared plus 2ah plus h squared. Then I still can't forget about this term. That would be plus a plus h. Right? Now this right here this is only covering this first part. That's only covering this. Whoops, excuse me, didn't mean to do that. Back that up. I wanted my highlighter and I got my pen instead. That is only covering this. That's the blue parentheses there. I still have to do the minus f of a. All right, so to fill this in, now I have to do minus, well, what is my just original function when I substitute in for a? That'd be a squared plus a. There we go. And actually, let me do those in, I'll do those parentheses in red to kind of help these things stand out a little bit. So that'd be red and red. So therefore, oh, I don't think I have a red highlighter. I can get one later. I'll make it purple. There we go. So that would be that section right there. Okay. So now that takes care of the f of a plus h and the f of a, but I still have to do the all over h. So now we're halfway there for finding our derivative, f prime. Excuse me. So right here, let's fill this in. Let's be a little more exact with what we're doing. The limit as h approaches 0, and this would be f prime of a. Okay. So now, combine like terms, simplify everything we can. So this is going to be the limit as h approaches 0. So when I distribute my negative here, I'm going to get a squared plus 2ah plus h squared plus a plus h minus a squared minus a. So now we can go simplify things. So I've got a squared and negative a squared. Then I have a negative a and a positive a. So after I get done with that, over h, we would now be left with the limit as h approaches 0 of, oh, and of course our goal is we want this h to divide away because I can't substitute in 0 for h until I'm no longer dividing by that. So let's try factoring out as well at the same time. We have an h left in this term, we have an h left in this term, we have an h left in this term. So let's factor out that h, and I'd be left with 2a plus h plus 1. And then that's all divided by h. So now when I simplify this term, my h would divide by this line, my h would divide with my h, leaving me with the limit as h approaches 0 of 2a plus, excuse me, that's the world's worst a, 2a plus h plus 1. Now am I able to evaluate this limit? And yes, I can. I can just substitute in 0 for h because it would no longer cause me to have a discontinuity or a vertical asymptote or a hole or however you want to look at it. So when I substitute that in, that's going to leave me with 2a plus 1. So therefore, the derivative of f of a is equal to 2a plus 1. Well, if you remember, our original function f of x was x squared plus x. So what I was talking about at the end of the class was, well, or we'll get back to that. The original function was x squared plus x, so this function over here is describing the slope at any given point. Now our original function was just a parabola, right? Some kind of parabola. We'll just do a quick sketch. We know it's opening up, something like this. Okay, great. So what this function over here is saying, what the derivative is saying is, hey, you tell me an x value, you tell me the x value 2, I will tell you the slope of the tangent line at 2 for that graph. And that number, as we can see, that slope is going to be changing for every value we pick. Some of them should be positive, some of them should be negative. So let's quickly test that. Let's do f prime of negative 4, just to see what happens. What would be the slope of negative 4? Well, very quickly you can see this would just be negative 8 plus 1, so that's negative 7. So therefore, at the x value of negative 4, we'd expect to see a slope going down, from left to right, going downward, at a steepness of negative 7. Now, as I move closer to the positive values, I'd expect to see my slopes starting to become less negative, less negative, less negative, starting to become more positive, more positive, more positive. So, and as you can see, if I do 0, therefore I should now have a positive slope of 1. So obviously my sketch isn't perfect. Let's go ahead and get this typed in here and see what the graph actually looks like. This would just be x squared plus x. So when I look there, So there you go. So you can see when I look at my slope right around 0, I'm now on this part of the graph, so it's sloping upward, where -4 had a downward slope. So anything past, somewhere it looks like right around 0, I should start having more and more positive, steeper and steeper slopes to have my tangent lines. So let's make this a little closer to reality. So the graph looked something like this. So therefore, we can predict if I substitute in the value 2. 2 times 2 is 4, plus 1 is 5. Right? So the steepness at 2 is steeper than an earlier steepness, and it will continue to grow. Okay, so that's what I wanted to make sure everybody saw and witnessed and whatnot. Now, the next thing I want to point out, just so the people who have seen calculus before don't have a gigantic leg up, it was the first rule of derivatives I wanted to point out, how you can check your answer at the end by looking at the beginning. So the rule at the beginning says if you have an exponent, it just comes out to the front, so it would be 2x, and then subtract 1. So therefore, if you think about it, this originally had a 1 on it, so the 1 would come out to the front, 1 minus 1. So this would be 2x to the first, plus 1 times x to the 0, and as we all know, anything to the 0 is really just 1. So therefore, you can see there's our answer. So let me throw one more at you really fast so you can see what your derivative should be without doing any work. So if I gave you f of x equals x to the 5th plus x cubed, let's make it 4x, 7x cubed. This is not happening. There we go. Minus 8x. Okay. So when I do this, the 5 will come out to the front. So that'd be 5x to the 4th. Plus 3 times 7 would make 21x squared. Minus, 1 comes out to the front, giving me 8. So there you go. So you can see I could have gone through and done the whole derivative rule that we had just done using the difference quotient and all that good stuff. But I actually rephrase it. On the test, you're still going to need to do it, but at least this way you can check your work and kind of know what your answer should be by the end. Okay, I hope this helps. Let me know if you need anything else.